All right. Hello, Hyderabad. Hope everyone is doing well. This is second virtual session for Grafana and Friends Hyderabad. So the first event was a success. We got really a great feedback about having the sessions virtually, and it's in a YouTube channel. People can view again and again, rewind the sessions, get most out of the sessions, right? So I'm really happy, and no, we definitely want to continue with the virtual sessions going forward as well, right? Let me share my screen to give more. Okay, so I'm sharing my screen. All right. So here with me is Ashwin from Redis. So for this event, we have collaborated with the Redis community. Redis is becoming quite popular now as a caching mechanism. Many enterprise level companies and it's now open source of Redis is being used widely now, right? I'll I'll introduce Ashwin after I give a brief, intro about what is Grafana and Friends Hyderabad doing currently, and what are our future plans, and then I'll hand it over to Ashwin. Right. So, as you see the meetup page, we have reached 3,824 members. I think that's a great achievement for Grafana and Friends Hyderabad. We when I took over in 2024 November, the count was the count was around 600 or 700 members. So I'm very much happy that we have reached this number today. It's really great. Makes me happy. To the entire Grafana and Friends Hyderabad organizers, the team, that we were able to get more and more members to join the community, show the enthusiasm, attend these sessions, physical or virtual, as we started last year. This shows the passion of the technical, the professionals towards the community, right? So I think that's a great achievement for Grafana and Friends Hyderabad. We also the spread a word. We look forward for more people to join, more professionals to join, contribute in all possible ways to the community, right? So this is our meetup page. Let me go to,
Just question. I think there is issue with the screen share. I think. Are you just sharing your screen?
sorry, Ashwin.
Are you still sharing your screen? There was
All right, my bad. Okay. Yeah, you catch. All right. I'll just, sorry about that. I just missed to share the screen. Happens. No worries. Right. So the page which I was showing, right, there's a meetup page. I talked about the number. Thanks to the attendees, the members who had joined the meetup group. That's a great achievement for Grafana and Friends Hyderabad. There is a Slack channel where we have active, say here on grafana.com. You would be able to see down at the bottom there's a community Slack. If you just click here, it will redirect it to Slack channel. You can just get the invite, join the Slack channel, and this is how the Slack channel looks like. We have a Grafana meetup Hyderabad page where we post the events, the photographs after the event, and there's a open channels. Those are Grafana, where we have great discussions about your queries. You have a beautiful dashboard created. You can share with the community. You have any specific doubts with the specific tools of Grafana, you can discuss about it. If you have any ideas, definitely you can discuss about it, and follow other channels for events, announcements, and other related things with the Grafana. Right, this is our Slack channel, and uh, right, we have LinkedIn as well. Okay, so coming back to our event here. Yeah, let me just right. Okay, yeah. As I said, we are partnered with Redis community. Glad that Redis community is spreading across India and other cities as well. I think this is the first meetup for Redis community in Hyderabad. Right. So Ashwin Hariharan is the developer advocate at Redis. So he'll be speaking on monitoring and optimizing RAG performance with Redis and Grafana. I'll be speaking, on how correlation works basically, because many developers or DevOps or SREs, ultimately they want the metrics, logs, and the traces to be correlated to actually investigate an incident. How that happens, we'll see in my session, right? And here our Grafana and Friends Hyderabad organizers. We have Navneet, Raul Chaudhary, Rishi, and Janvi Logani. So we work back in the background. Everyone does their job to ensure that we have these events and sessions provided to the community. Yeah. Now, talking about me, so talking about me, I'm Sapal Singh. I'm the organizer for Grafana and Friends Hyderabad community. I'm a cloud AI and observability architect. Um, I'm a Grafana champion. I'm a certified Kubernetes application developer. I also mentor grads, or if someone reaches me out, I generally tend to help them in all possible ways. I kind of do a mentorship as well. Yeah. So I have been, in observability space for quite some time now. It's been over 8 years, working on Grafana products, and solutionizing observability, because it's key to know your system insights. Yeah. So without observability, it's really difficult, and uh, you know. Uh, the developers or SRE, if they do not get an insights of the system, it's really difficult for them to get into the inside of the system, investigate and resolve an incident. Of course, we have moved a long way with the AI, but still understanding the core concepts is very important, right? So I have been in this space for a long time, delivering solutions around observability, uh, and running the communities, and actively participating in speak as a speaker. I've spoken at various events in Hyderabad, and outside of Hyderabad as well. Yeah. So coming to the Redis community, right? So, no, thank you so much, Ashwin, Hariharan, for joining us today. It's been great that Redis community has joined Grafana for this meetup. Speaking of Redis, if I ask, right, why Redis?
All right. So why Redis? Oh, great question. So, um, I guess Redis has, when first began, it started from being just a cache. But now it's evolved from just being a cache to becoming almost like a real-time data backbone, you can say, like for AI systems, especially agent-taken large language model powered applications. So you can imagine Redis to fit in a variety of use cases. For example, memory layer for agentic AI, like short-term memory, where you want to maintain the conversation state in your agents, to long-term memory, cross-session memory. So in these cases, Redis can provide, basically, it can act as a key value store for session state. Um, we also, I know over the last couple of years, there's been a variety of data structures that support, added to Redis, for example, vector embedding storage, similarity search, hybrid search. So which makes it a very usable and crucial component for RAG pipelines, memory retrieval, and personalization, etc. Right. So I think that's where
Right.
Redis becomes like a very core piece of architecture, especially if you're trying to put something in production, and you want to um, it's just not about having a memory, but it's also about having access to data really fast. So that's where Redis can fit in. Yeah.
Cool. That tells us how important Redis is. With that, I welcome you to start with your session, Ashwin. Yeah, over to you.
Okay, sure. All right. Uh, right. So I'm just going to share my screen. Uh, okay. Let me know if you can see my screen. I think it
All
should
right.
start.
Yeah.
Okay. Okay. Great.
Yes.
Okay. So, yeah. Hi, everyone. Hopefully, you are watching this wherever you are. Maybe it's from your home, or maybe from your office. So, yeah, my name is Ashwin, and I'm very excited to have this discussion on this topic that is becoming increasingly important for anyone who's deploying AI, which is monitoring and optimizing RAG performance with Redis and Grafana. Just a quick background about me. So I work as a developer advocate at Redis, and prior to Redis, I worked as a full stack developer for approximately 8 years. And I've been part of quite a few communities, starting from Free Code Camp to Free Software Movement of Karnataka. Most of my community work has been in just writing a lot of technical content on full stack application development. And lately, after joining Redis, it's been quite some work around AI and performance enhancements around RAG. So, as many of you know, moving a generative AI application from a proof of concept to a production system. Now, that introduces a new set of challenges, especially around performance and efficiency. So, the focus of this session today is on how to meet some of those challenges. So, we will explore how if you leverage technologies like Redis for its speed and reliability, and Grafana for its observability capabilities, that will allow you to build RAG applications that are not just smart, but also they are but also fast and scalable, right, and also cost effective in a real world setting. So this session is dedicated to that. What are the practical steps you can take to get the most out of your generative AI investment. So here's what you'll learn. So first, we will just look at some common generative AI patterns. We'll just do a very quick deep dive, not a deep dive, but like a quick dive into what is RAG, and as well as a very quick overview of agentic AI, what they are and how they are used. And I'll just show you a very quick demo. Then we will talk about, focus on optimizing performance, specifically about specifically by reducing latency with semantic caching. This is like a generative. This is like a pattern
Mhm.
of vector embeddings. So this is a very powerful technique to make your large language model powered applications faster and more cost effective. And then finally, we will talk about observability. We'll cover how to get a handle on your system's performance by measuring cache effectiveness and then assessing cache efficiency. And we'll look at some Grafana dashboards. So throughout this presentation, I'll just show you like three related demos to show you these concepts in action. One for agentic AI, one demonstration for how semantic caching looks like, and another one would be how you can optimize your RAG with the help of Grafana. So yeah, so let's
Yeah.
talk about RAG, which is a most common use case. As many of you are watching are probably aware of this. This is the most common technique we see in generative AI today, right? So at its heart, RAG is a way to leverage semantic search to retrieve and inject um, relevant external documents into the LLM's prompt. So this is how we overcome the common challenge of LLMs, which is like their knowledge is limited to their training data. So if you look at the workflow, there is a preparation stage. In this stage where your documents, whether they are knowledge-based articles or it could be internal demo memos or technical manuals, PDFs, they're all first embedded. Basically, they're converted into numerical vectors and then they're stored in a vector database. Now, vector database could be anything. Like in this case, I'm just using Redis here. Now, next, what
Mhm.
happens is for the steps when a user asks a question. So, as a user sends a message or poses a query into the system takes that message and it's going to perform a vector search. It's going to identify the documents in your database that are most semantically relevant to the message. And then these retrieved documents are then once again passed to the large language model with the original user query. And then the large language model now uses this information, these documents to respond to the user's query. So now, because now you've given it the right context, the response generated by the large language model is very grounded. It's very grounded in facts. It's factual, external information, which dramatically it reduces hallucinations and it improves accuracy. So, and the applications for this pattern is quite a lot. You see RAG being used everywhere. For customer service chatbots and knowledge bases. You might have like an application for document analysis and workflow automation. So many of them are there. Now, when we talk about AI agents, now what exactly do we mean? So because that's like the next step in terms of complexity. It goes beyond than your just traditional RAG. And when I first came across this term AI agent, like that felt to me like the ultimate in buzzword lingo, right? Like everyone was talking about agents,
Yeah.
but if you quiz them, if you quiz each person, everyone seems to hold a different mental picture of what an agent is. It's almost like you're trying to
Absolutely.
humanize. Yeah. So the way I understood, perhaps after coming across multiple definitions, I think this is the best way I think I can put it. So an AI agent is a system that uses a large language model to decide the control flow of an application. I know it's a little bit, it's a slightly technical definition, but I think it sort of fits. It's basically a large language model with capabilities beyond just searching for information or acting as a substitute for Google search or just generating a bunch of text. So it's not just a chat bot that responds, it's actually a system that can actually do things for you. It can take actions. That's the crucial difference between a RAG based system and a large language model. So think of it this way: a chat GPT is like having a really smart consultant, well, it's also now become an agent. That's
Yeah.
when it first began. It didn't really have the ability to do anything besides just giving you a bunch of text. So if you think of that mental model, it's like having a really smart consultant who can give you advice. Whereas an AI agent is like having an assistant who can not only give you advice, but they can also execute upon it. For example, uh, hotel reservations. When you book that hotel room, or file that support ticket, or update that database. So the key here is that the large language model isn't just generating text, but it's actually making decisions about system behavior. Should the system search for more information, or should the system ask a clarifying question, or should it execute this particular action? So it's also reasoning through its decision, and it will perform an action eventually. So, and also the other ability is, depending on how sophisticated your AI agent is, it can learn over time through trial and error also. So now let's look at a demo now. So I want to show you a very quick demo of how this looks like in practice. So I will. So what I have with me here is a shopping assistant, similar to, think of it as Blinkit, but powered by an AI agent, AI assisted Blinkit for shopping. So this will demonstrate, semantic search, agent orchestration, and persistent memory. They're all like working together. So So here is how I'm going to interact with my AI agent. So this is like a shopping assistant, such a chatbot. So I'll just start with some. So how, just like how we have vibe coding, I want to show you like how vibe shopping can look like. Okay. So let me ask a question like, what do I need for, oh wait, uh, I am looking for pasta ingredients. Okay, so this is running on my local system, by the way. So we can see the logs, which would be somewhere here. Let me just expand this slightly so that it's visible. So what I want you to see is how the AI agent understands the context and finds relevant products. It's actually going through my database, which has products, and they are saved there using with also their vector embeddings. And so it's finding the relevant product even with a very broad description like this. Okay, so it's taking a few seconds. It's thinking through the recipe for pasta, and then it's searching through the product database to find actual products you can buy. Okay, so if you come back here, so you can see uh, it gave me a complete ingredient list, and found actual products with IDs and prices. And you can go and look at one specific product. So it's an actual product from the database. Okay, but as I said earlier, it's not just about retrieving a bunch of stuff from your database. It can actually do much more than just a product search. So you can use this to add something to the cart. So let's say I want to buy basil and cheese. So I can say add items uh, 5 and 6. I don't even have to mention the whole uh, product name. I can just say add items 5 and 6 to my cart. And if I hit this, and if I look at the log, so our agent has access to a bunch of tools. The previously, when it was looking for ingredients, there was a tool that I had created called Fast Recipe Ingredients. Now, when I'm adding something to the cart, it's using a tool called Add to Cart. So using this tool, it is actually able to execute and perform an action. In this case, it added some items to my cart, and these are the 2 items. So if I just say view my cart, it's going to access my database because that's where my cart items are stored, and it's going to fetch it. Yeah. So this is an example of an AI agent. Like, now the agent has confirmed it's added something. Now let's back
Looks
to
cool.
the,
Yeah.
yeah. Uh, okay. Sorry, what is this? Okay. 1 second. Just refresh this. All right. So now that we saw an agent in action, Now, a standard generative AI interaction is very straightforward, as you saw. Like, user sends a message to the large language models, and then they get a generated response, right? But as simple as it sounds, it's expensive. Like, especially now, if you go and take this system that we just saw and you just put it in production, um, there are some considerations you need to bear in mind. Like, this was a very quick demo that I just showed. But what happens when you actually put it in production? So it can be expensive in both time and money. So one thing that you might have noticed, that each response, so when I typed the question and I was waiting for a few seconds, like it can take up to, now this is a very simple question, by the way, and it was a very simple interaction. I just wanted to find some products. But depending on your specific application, any response from the generative AI, your RAG application or your agentic AI can take anywhere between 5 seconds to 10 seconds under optimal conditions, right? So think about that latency when you are trying to provide a real-time, seamless experience to your users, right? So now some considerations or questions to keep in mind. One of them is, is every response supposed to be unique, or does every query deserve a unique response? Now, the reality is, based on industry research, often when users type queries, and that's how people interact with the agent anyway, or with RAG, roughly 31% of queries turn out to be redundant or very similar to one that has been asked before and answered. There are studies around this, which I can share later. So when you introduce LLM into an application, whether it's for customer support or shopping assistance or technical documentation, there's a good chance that your users are going to ask questions or queries that have been answered before, like over and over again. For example, imagine a customer support agent. You might have something like, what is your return policy? Or how do I reset my password? Or what are, let's say you're trying to book a hotel, and then you have a question like, what are the business hours, right? So these are questions that many users will ask often, again and again. So generative AI has a kind of a waste problems, like, and redundant queries can be expensive. So now if you see the graph over here, based on the research, it just shows how much overlap there is. So you can see the dark bars, they represent duplicate queries in a variety of samples. Okay. So the 31% figure is actually crucial. Nearly a third of queries that turn out to be questions that have been answered, or semantically very similar. Okay. Now, if you're sending nearly one third of your users' questions to an expensive agentic AI system that you've developed, high latency LLM call or triggering an agent workflow, when you could have provided an instant answer. So then the conclusion is, isn't there a lot of waste here? So this waste in cost and time is what we're trying to address. Okay. So if you take that cost and latency problem, we can see how scaling also becomes quite challenging, because the numbers tend to add up very quickly. So now imagine a situation like, here we have a bank with 50,000 employees. If each of those employees, now they're using their internal knowledge base, just 5 times a day, okay, then the cost of RAG calls with a LLM like GPT can easily reach like $400,000 a year. And now beyond the cost, the other major headache is high latency. Like, maybe you do not have a lot of users in your application. Maybe you do not have 50,000 employees, internal employees. So maybe cost, probably, well, it's not very big of a concern, but there is a concern of latency, which actually impacts UX and performance. So if you look at the average latency numbers for LLMs like GPT-4 or Claude, like the one that I use is GPT-4 Mini, the one that I just showed in the demo. So it can take up to nearly 10 seconds for an answer to be fully generated and come back to the user. So in a real-time application, 10-second wait can sometimes, result in, unsatisfactory UX. Right? So to scale these systems and actually make them useful, we have to solve for both problems. We have to lower the cost, and we have to drop that latency also. So how do we do it? It's the basic caching principle from the times we know what is a cache, it all boils down to the classic age-old principle, like don't repeat yourself. If you already done the work, why do it again? So conventional caching, as you probably have used before, it's like an exact string matching. Like this is before we had vector embeddings. Like you had to write the exact string. So which means if someone has searched for wireless headphones, let's say, that will not match Bluetooth headphones, but they both mean the same thing, right? So that is a conventional caching. However, what we will be talking today is something like semantic caching. So imagine the user's query. The way semantic caching works is, imagine the user's query starts with the agent. So before the agent even or your system even considers spending time invoking a large language model or going to your main database and doing a vector search, the first thing it can do is check the cache for similar queries, not exact queries. It can check for similar queries using a vector search. So there are two possible outcomes when it does that. When it does check the cache, it can get a cache hit if the question has been answered before, meaning if it's already seen the question or it's a semantically identical question from before, in which case we can just bypass the whole agentic workflow completely, and the system can just respond from the cache instantly. So no need to invoke your RAG pipeline, no need to invoke agentic workflow. You can just bypass them all and instant response because it's already been answered. So this is where we tend to see a huge cost savings and performance boost. Now, secondly, if there is a cache miss, that means this question has not been answered before. It's a unique query. It's not been seen by the system before. Then in that case, you can invoke the large language model API. You can invoke your RAG. You can do a vector search, everything, everything that you need to retrieve and generate a response. So once the system has generated that expensive, slow but necessary response, you can take that new question and answer set, and you can save them in the cache, and also you can serve them back. So this way, if anyone else in the future asks a similar question, you're already ready with an instant hit, an instant answer. So that's how semantic caching works in principle. So how does it look like? So going back to the demo, so here I've logged in. This is a different user. I'm here. This is a user called Ashwin. Now I notice before I had asked this question, I am looking for pasta ingredients. Now I will go to my next window where I am a different user. Okay. Now I'm going to ask the same question, but I will phrase it differently. I'm not going to ask the exact same question. I will say, what do I need for pasta? Hopefully the demo gods are with me today. Yeah. So you see,
Yeah.
it was instant, right? So the semantic cache, which is powering this feature, which is powered by Redis, recognized the semantic similarity and served the cached response. So there was no large language model call, no tokens burned, and you still have the same high quality answer. So this is an example of how it works in action. Okay. Now, going back to the demo once again, this you just saw it working now. Okay, so now I'll just show you a briefly about how the architecture looks like. As you can see here, every question or user query follows a cache first pattern. So Redis Langcache is semantic caching as a service provided by Redis. You can use the open source version of Redis also, in which case you have to do it a lot of stuff manually. If you're using Redis Langcache, most of the stuff related to setting up a semantic cache service, and just managing it overall on the cloud is just taken care of for you by Redis Langcache. So you can just try it out. Yeah. Or you can use the open source version as well, like which is, in which case you'll have to use Redis VL for Python, and write the cache, set it up yourself. But anyway, so if you see here, cache, it's all following a cache first pattern. So cache, so let's say user has asked a question. If it's a hit, if it's found in the cache, it means an instant response. So we just, we just bypass everything else. We just serve the cache response back to, to the user. So this way, before doing any expensive AI processing, we check if we already know the answer. Now, if cache miss, if that thing was not there in the cache, that's when we run the full AI workflow, which is what we had to do the very first time. It took some time because we did not ask the question before. So this is where your whole agentic AI workflow comes into the picture. So now for my particular application, I'm using LangGraph, which does the job of coordinating multiple AI tools, managing the state between calls, and deciding when the workflow is complete. And then finally, so my agent has access to, roughly speaking, 4 tools. There is a search product tool. This is going to do a vector search to find items, right? Even with fuzzy descriptions. There are some tools for cart management, one to add to a cart, one to view the cart. And there is a tool which breaks down a question like this into its constituent products. Like for tomato soup, I need some products, right? So ingredients basically. And then once it's generated a response, we then save the result back to the cache, okay? So that the next person who also asks a similar question gets an instant response. And this is where, databases like Redis can really shine for providing the AI the context needs really fast, okay? Now, what you saw was like a demo, but as powerful as semantic caching is for optimization, but it's not like a set it and just forget it sort of a solution, right? So the reality is you still need to optimize for it, and you can't optimize what you can't measure. So many times, often generative AI applications, they're just flying blind. Companies might be spending thousands of dollars in LLM calls without knowing where that money is going. So, the universal question for generative AI optimization, whether you're implementing semantic caching, or you're, trying to evaluate different models, or you're trying to tune your prompts, or wherever you're trying to optimize your RAG pipeline, you need to answer one critical question, which is this optimization worth the investment? Okay. So for example, with our specific use case, one would be like measuring cache effectiveness. Are we serving the correct results from the cache? Because a semantic match is not an exact match. So we need a system to ensure that the model is serving results from the cache properly. And performance, are we hitting the cache often enough? And can we serve results from the cache quickly without negatively impacting the overall round trip, the latency of the application? So we need mechanism. We need to be able to answer those questions. If you ever want to, let's say tomorrow, decide to update your cache, you want to invalidate them, you want to refresh your memory, maybe your knowledge base has document changes, your cache might need to reflect that instantly. How would you know? So that's where you need observability, right? This is how you prove whether an optimization is worth the time and effort. So you need the ability to observe and measure the hit rate, latency, the cost savings, and also the quality. So without observability, you're just operating in the dark. So if you can't confirm the accuracy of cache hits, you can't quantify the cost savings or the latency savings that you've been promised. Okay, so here is where Grafana comes into picture. Okay, so I'm going to show you next a Grafana dashboard, okay, that demonstrates how to gain actionable insights on a specific, this specific RAG optimization strategy, which we just talked about. Of course, Grafana can be used for a multitude of observability concerns, but because uh, for this purpose, for purposes of this session, we'll focus on a very few use cases, and namely semantic caching. So we will see how to answer critical questions, like for example, is it even working? Is it worth my time? ROI metrics. Is it fast enough? Is it improving the user experience? Right. So where can we improve further? Optimization opportunities. So yeah, so this demo is not going to be very exhaustive, but then we will not cover every possible observability concern or metric you might need for generative AI, but we will focus on the specific metrics that matter for the most common optimization challenges. But here's the architecture that you're just seeing on the screen. So my RAG or the agentic AI application is built with Node.js and LangGraph, but you can be using whatever. You can be using Java or Python or Fast API. So every time a request is coming in, um, we track it through the entire pipeline, right from the initial query through the cache lookup, potentially through the LLM and back to the user. So the way the metrics collection works here is we are using the Prom client library. The Prometheus client library for Node.js to define and record metrics. So what I have done in my application is I've collected custom collectors in my application code. That reminds me, let me just pause it for a really for a second and just run my collection. I need to run a script that starts collecting my data, and I'll explain more about what I'm doing here as I walk you through the dashboard. Um, okay, back to my demo. Where is it? My screen is visible. Okay, sure. Okay.
Yes,
Yeah.
Ashwin. Yeah.
Okay, so yeah, I just wanted to just run that. I just remembered to. Okay, so what
Yes.
I'm doing is basically I'm using the Prom client library and then I've used defined some custom collectors for my application code. For example, I want to track cache hits and misses, counters, LLM token usage and costs, response times, end-to-end pipeline duration, like histograms, cache lookup performance, a bunch of them. Okay, so like operation types, what kind of queries are being cached? That's the kind of information that I'm interested in. And my application exposes an endpoint called slash metrics endpoint. Now this endpoint is going to return all my current metric values in Prometheus format. Okay, then I'm going to use a Grafana alloy. Here's where things get a little interesting. So this Grafana alloy is a telemetry collector. So you can think of it as a telemetry agent, not an AI agent, which is going to scrape your metrics endpoint every so and so interval. Like in this case, it's collecting it every 15 seconds, and it's going to enrich the metrics with labels. What job environment, what version it is. It's going to do a little bit of data enriching, and it's going to send the metrics to Grafana Cloud. That's what it's doing. So now why alloy? Why have I used alloy? Because it just simplifies telemetry collection. It consolidates multiple collectors into one solution. So you know uh, so for example, in this use case, I could just run it as a single binary with the help of Docker, uh, and you can use it to collect traces and logs as well, which we're not using it today, but you can use it for that as well. And once it goes to the Grafana Cloud, Grafana Cloud is going to provide the dashboard UI. So it's going to connect to the Prometheus backend and query the metrics using Prometheus query language. So now the dashboard that which I'm about to show you is built using those PromQL or Prometheus query language queries. All right, so now let's look at the dashboard now. Coming to the demo. Not able to switch the. Let me just stop and restart my sharing once again. Some issue. Okay, hopefully you can see my screen now.
Yes, Ashwin. Yeah.
Yes. Okay. All right. So now let's look at the dashboard itself. So now what I have done is I've organized it into five, maybe like I think five rows. One, two, three, four, five rows. Yeah. So now each row is going to tell a story basically. I just started it now. So let me show last 15 minutes. Okay. Okay, so let me tell you what is showing here. So basically, there are you know the there are a bunch of panels over here. So in the row one, you're going to see some key summary of some key metrics. Okay, so this is like your at a glance view. Okay, so there are these four side statistics or panels that give you some headline numbers. So one of them is the cache hit rate, then cost saved, cache savings percentage, and the response time speed up. Okay, and I will go into detail of what each of them are. Second row is all about user experience. This is the row. These are like having two panels that frame the value in in user centric terms. Time saved per request and repeat query rate. Okay. The third row is about cost analysis. There are two time series panels which show cost trends over time, and cost breakdown. Actual cost was a saved cost. I'll again go into it more detail. Row 4 is performance analysis. There are two time series panels showing latency related metrics, and one of them is response time, other one is cache lookup performance. And the last row is about operational insights. So cache behavior, basically, cache saves by operation and cache hit rate over time. Okay, so I'll tell you what I've done now. So when I ran this command, going back to I ran a script. Basically, what it's going to do is it's going to load. It started a load test simulation because I don't want to go and um, I can't keep going back to my um, app and keep manually writing queries. So I wanted a way to do it fast and automatically. I wanted to stimulate a bunch of users. So the script that I just ran is generating some traffic to this application, okay? So that we can see actual data flowing through Grafana, okay? So it's quite simple. It's a simple script. It simulates real user behavior. So here's what it's doing. I can probably just walk you through the code very quickly. Basically, this is how the script looks like. Um, Without going into too much details, so I have query categories with different cache behaviors. Uh, so I have broken down a bunch of queries into different categories: recipe queries, product searches, knowledge queries, and variations of all of them. Every query type has some variation, multiple semantic variations of the same question. For example, what ingredients do I need for pasta carbonara? And show me the ingredients of for carbonara pasta, right? So examples like these are semantically similar queries. Okay, so they should hit the cache even though the exact wording is different. That's what I want to test, and I'm just trying to simulate traffic patterns. Okay, and it's going to keep running for the next 30 minutes. So the script is sending API requests to our API endpoint, the endpoint which allows us to talk with our AI agent. And each request is getting tracked by our Prometheus metrics. That's what's populating the dashboard that you just saw over here. Hopefully that made sense. Now let me walk you through what each panel is actually doing. So what is this doing? So this is a percentage of queries that are served from cache versus those that require a large language model call. So what do you expect when you are doing load testing or when you're seeing real world traffic? Okay, the very first time you should expect to see that the hit rate is almost like negligible, 0%, because the cache is empty, right? Um, but the hit rate needs to start climbing up because now the cache is being filled. Okay, so you will see it jump from 0 to 10%, then 20%, then 30%. Now it's like 52.6%, right? So the rate of increase depends on how repetitive your queries are. Okay, so with our test data, we are typically seeing like 20 to 30% hit rate just like within 10 minutes. Okay, now after some time, you should see that the hit rate will just stabilize, maybe like 60, 70% for this particular use case. This is like, now your cache is mature. So now the exact number will vary depending on how diverse your queries are. Okay. So if your hit rate is below 30%, what does it mean? It means you might be, your users might be using your application differently than you thought. There would be too much of query diversity for semantic caching to be valuable. But if you're seeing 50 and above, then you're like, this is the sweet spot, right? So it's actually making a real difference to your application by introducing caching. Now, moving on to total cost saved. Now, this is like a cumulative dollar amount saved by avoiding large language model calls through cache hits. So, what do you expect here? Again, initially, you don't see much savings because there are no cache hits there. You have to invoke large language model. Your generative AI, your AI agent needs to be invoked because you don't have anything saved in your cache yet. So, this is your money burning phase. But after some time, maybe like 5 minutes, 15 minutes, depends on how your application is. In this case, after maybe 5, 10 minutes, you start to see some small savings as the cache hits start to begin. So you will see it climb from 0 to 0.1 and $0.02, etc. So the rate of increase accelerates as the hit rate improves. Okay, and finally, the savings will accumulate linearly with the hit rate. So this might seem small, but remember, this is just a demo with very limited traffic. So if you scale this to production traffic, and you're going to look at hundreds, potentially even thousands of dollars of savings per month. This one is cash savings percentage. Again, this is going to just do the same thing, but in percentages. Like what percentage of your total LLM costs are being saved by the cache. So again, you will see a very similar pattern. It's going to have a very cold start for the first initial use because there are no savings yet, but then it will start climbing. Now this one, response time speed up. This is going to tell you how many times faster cache hits are compared to the miss, like compared to the compared to how fast your system is if your system is invoking the full pipeline, the RAG pipeline and the AI agent pipeline. How fast is caching compared to that? So again, what you'd expect, as usual, you will see for the first few minutes there are no cache hits yet, so you can't even calculate a speed up. But as your cache starts getting hit, this the stats is going to show a value, right? So it's going to show that there is a significant speed up. In this case, there's a significant speed up. That's because if you're missing the cache, if you're invoking your LLM, that's going to be taking anywhere between 5 to 10 seconds. But if it's a cache hit, you're going to serve in less than a second, as you saw in the demo. And here, this next one is time saved per request. It's just showing you, it's calculated as the difference between average miss time and average hit time. So just like this is what you would expect to see if your cache is working. You will see how much time is being saved. It's almost like 10 seconds on average is being saved per request. Okay. Initially, when it first began, there was no time being saved at all, but now it's starting to build. So you're seeing quite some savings over here. Repeat query rate is just what percentage of queries are semantically similar to previous queries. This is just like cache hit rate, but it's just worded differently. This is more like for product, I think. This metric shows proves the value proposition of caching. If 65% of queries are repeats, then semantic caching is clearly valuable. right? If only 5% are repeats, then you might question whether this adding this component is worth it or not. So this is identical to cache hit rate, but that's intentional, but they're the same metric, but just framed differently. Cache hit rate is more of a technical framing, like 68% of queries hit the cache. Whereas this is more of a business framing. 68% of queries are repeats. That's the difference here. So different audiences, because you can. That's the beauty of Grafana. You can design your Grafana dashboard to cater for different audiences. Different audiences care about different framings. Engineers care about cache hit rates. Product managers care
Right.
about user behavior patterns. That's the advantage of using a dashboard like this, right? Now, cost breakdown. Now, what this shows is a stacked time series visualization. It's showing actual LLM costs, which are in red, and saved costs, which are in green over time. So the total height of each bar is will represent what you would have spent without caching. So what do you expect initially for the first 5 minutes? Only reds. Mostly it's just red. There are, it's an actual cost, not much of greens here. So the red area grows linearly with time, of course, because LLM calls are getting accumulated. But as you keep going, now you see more greens like appearing on top of red. So the red area growth is slowing down, whereas the green area growth is sort of accelerating as you keep moving forward in time. Because now you're getting more cache hits. So you can visually see the cache taking over than the system. Okay. And then it becomes steady after some time. So what's the business story here? Because that's what we care about in dashboards, right? So red area means money that you actually spent on LLM calls, cache misses. Green area means that money that you saved by avoiding LLM calls, cache hits. And the total height just represents what you would have spent without caching anyway. That's the ROI, the business story. Token usage trends. This is like a 3 time series lines showing prompt tokens, which is in blue, completion tokens, which are in purple, and save tokens over time. So again, you will expect the same trend. Blue line prompt tokens climbing steadily, purple tokens climbing faster, because sometimes purple ones can climb faster if the responses are taking more time. And then green line is almost always at 0, but then it starts to climb up. Yeah. So tokens saved are getting larger, right? So they're all going to grow at steady rates in our as more users keep using it. This one is interesting. What is P95 response time? Basically, it means this shows 95%. Okay, so this is response time for cache hits versus cache misses. So P95 means 95% of requests are faster than this value. So what do you expect initially? It's only red, like there's only cache misses, only red line visible. It's almost taking like, wow, 18 seconds on average, right? This is your baseline performance without caching. You can imagine this as a baseline. No greens in the beginning yet because there was no cache hits. And then first your cache starts to get cache warming. So green line appears over here, if you notice, once cache starts getting used. And then this is where you can see how huge of a difference it is. If it's a hit, it's less than 500 milliseconds, right? For the that means 95% of requests are faster than this value, the green value, if it's a cache hit. Why this
Right.
matters is because this panel proves the performance value of caching. The visual gap between red and green is so dramatic, as you can see. It immediately shows how much difference it makes for user experience. Yeah, I'll just probably took quite some time here, but I'll just wrap up this part as well.
Yeah, I think
This is
it was. Sorry.
yes.
It was quite insightful, Ashwin. I mean, it was. It's very important to, for the audience as well, to understand, right, how the metrics are visualized on Grafana, and
Mhm.
why observability is really critical, in terms of, the parameters here showed, right, with respect to Redis. And this is live dashboard, right? And that's the
Yeah,
beauty of Grafana, so yeah, carry on.
yeah, okay. Yeah, that's a good point. Yeah. Yeah, just three more. Just walk you through this a bit quicker. So this is P95 time to look up queries in your Redis semantic cache. This measures how fast the cache itself is. So again, cold start in the beginning, so it's taking a little bit time. This is the time to search for um, this could be probably be your vector database. In my case, I'm using Redis for both caching and also for my actual vector database. So the difference is not huge. But if you replaced with maybe your main database was say some other database, not Redis, you would see a huge difference over here. Like you would see that the cache lookup performance drop from orders of magnitude more than this to milliseconds. That's what you would expect to see. But the curve would basically, the trend would still be similar. You would see a cold start at first, it's taking time because your cache isn't being used. And then it might increase slightly once the cache starts filling up, and then it will stabilize after some time. This panel, cache saves by operation time. This is very nice. Now you want to know, this is basically a pie chart showing which type of operations in your system benefit most from caching. That's because your agentic AI might be using sub agents. It can be a multi agent system as well, or it could be an agent which is using multiple tools, doing multiple things. So, which type of operations do you think you would benefit from cache? That's important to know. So this is a pie chart that breaks down, is just giving a quick breakdown. I'm just tracking tools for simplicity purposes, but you can track virtually anything over here, any operation. So what you would expect is, again, in the beginning, because you don't have much queries types anyway, you will see very small slices of data, not enough data to show any meaningful distribution, at least in the beginning. But once you know more and more users start using your system, they would be using it for a variety of reasons. Some people would be, in this example, in our shopping agent example, some people would be using it for product searches. Some people would be using it for adding things to a cart. Imagine someone is trying to do a trying to just look up something like, what are the what's the what are the return policy of a particular item. Let's say, if you this is like a grocery example, but imagine something like Flipkart or Amazon. Like, people might be using raising a support ticket, for example, right? So many different operations that you can imagine in a full-fledged e-commerce application. So you want to know which ones of them can benefit from something like cash, right? So you want to track those as well. So once more people use it, you will see a very clear distribution coming up. So now this keeps changing over time, but let's say, let me change this to 30 minutes. Now you can see more slices over here, right? So in my case, what the distribution is telling me is, my I think these style of queries, like knowledge base, can benefit most from a cache. Okay, like what let's see what kind of knowledge questions. Sometimes people have questions like this: what is the difference between baking soda and baking powder? uh, what temperature should I cook chicken to? Like, I don't know. So I've just given some examples here, right? And product searches benefit quite a bit from caching. So, people will be asking questions like this: organic tomatoes, whole wheat pasta, fresh basil, Greek yogurt, almond milk. So these are some of the examples of operations in this particular case, where you can see a very clear benefit of improving your performance. So this is the business insight. Users are primarily asking product search related questions, Users need definitions and explanations. That's where this tool is being used, the one in the green. Um, and People prefer direct questions over just, people prefer using direct searches over using over questions like uh, ingredient search. That's the kind of business insights you can gain from this pie chart. And finally, we have a time series line showing how cache hit rate changes over time. Very similar trend that you can expect to see. Initially, it's just a flat line starting from zero, no cache hits yet. This is the before state, and then once we start saving things, it just keeps climbing up. So this will show you. Um, uh, Basically, it's showing whether your cache is still warming up or it's being used to its potential. I mean, because you don't want your cache to just remain idle, right? So if it's declining, then something is wrong. But if it's climbing up and if it's holding steady, then that means something, you're doing things right. So that concludes. I can go into more detail, but we are running short of time. But so I will just wrap it real quick based on what we covered. So back to our presentation. Um, yeah, so just a quick recap. So conclusions are basically, yeah, you saw that the performance improvement is dramatic and it's consistent, right? So it's not just a marginal improvement. So without cache, without these performance enhancements, users might have had to wait for 15-20 seconds for answers, whereas with this, users just had to wait for less than a second. So uh, the perception of user experience is very different. And the overhead that you saw with semantic caching, even if it's taking 200 milliseconds, it is still modest of magnitude faster than a LLM call. Okay, that's the other insight that you saw. And different operation types have different performance patterns. Not all query types benefit equally from the same optimization, so you might have to look into those. That's what the pie chart indicated. And your cost savings scale linearly with traffic, right? So the percentage of savings the percentage of savings remains constant, but the absolute dollar savings, that scales linearly with traffic. So the more traffic you have, the more money you save, and the more your cache, your semantic caching, and these performance optimizations become more valuable. And what you can also expect to see is user behavior is more repetitive than expected, right? So users don't ask the exact same question twice, but they will ask semantically similar questions all the time. Okay, and that is where you can leverage, if you know user behavior, if you've done some sort of A/B testing, you can leverage that knowledge to actually improve your application. So yeah, that's the recap. So we just started by discussing the challenges of RAG in production, specifically the high latency and escalating cost due to redundant queries. But the concepts that we discussed are it's about enhancing the user experience. So the problem is when you build applications for generative AI, you don't want to be optimizing blindly. So you don't want to be making architectural decisions based on intuition. You want to do them using data, and you don't want to just tune your prompt without quantifying the impact. So generative AI observability that requires generative AI specific metrics, because your traditional metrics are not enough. So you have to not just track request latency, but you also have to track LLM latency, cache latency, right? You have to track error rates. You can extend this dashboard even further if you wanted to. You can track, maybe, for example, extend the dashboard to include hallucination rates, retrieval accuracy, cache quality, and you also want to track the infrastructure cost and token cost, LLM cost per request. So first you have to build observability and then you have to optimize. So you need to know the baseline. What are your current costs? What are your current latency levels, right? And if you did something, did it work? And if it worked, then by how much? So use data to guide your optimization challenges. That's the takeaway from here. And instrument your code with Prometheus metrics, send metrics to Grafana Cloud or maybe a self-hosted solution. You can use Alloy for that, Grafana Alloy. And you build dashboards to visualize the cost and performance and effectiveness and UX. And use the data to prove your ROI and guide your optimization challenges. So that's the takeaway. Hopefully, you gained something valuable from this session. And if you want to learn how to use Redis in your specific application for some of these challenges, you can access some of our courses. They are for free at Redis University, and you can. It would be great to have your feedback also. What you thought? What are your thoughts on this session? Does this make sense for you for your application? And if there's anything specific that you wanted to ask, you can share that in the feedback form as well. And this doesn't have to be the end of the conversation. So feel free to reach out to me on LinkedIn, and I'm always happy to discuss more about this further with you. I would like to know what you are building in your organization or in your personal projects, and let's keep the conversations going on. That's it. Thank you. Yeah.
Thank you so much, Ashwin. That was a really insightful session, I would say. I've seen, I've been to Redis University trying to, do some courses, then, watching videos online, or, trying to experiment with the, Redis implementation. But I think, this session is really a valuable session in terms of the continuity which I showed, in RAG, and explain about the semantic search, vector search, and how observability plays a key role, with Grafana dashboard showing the insights of the system, right? I think this session will help the developers, SREs, or the professionals who are started using Redis, or who maybe who are not aware of it, but they now have a great insights of where to start with Redis, how important is Redis, and of course, you will be available if there are any queries. Yeah.
For sure.
So
Yeah.
yeah, no, great. I mean, great session. Have seen many sessions, but in a while, I think this was really great session, with all the flows, with the demo, and with the live Grafana dashboard. Yeah, thank you so much, Ashwin. Yeah.
My pleasure. Yeah.
Okay. Now, yeah, so we have seen so much about how Redis plays a key role in today's applications. Okay, let me share my screen first, and then right. Hope you're able to see the screen. No, no, yeah,
Yes.
yes. All right, good. Okay. Yes, and thanks for showing up the uh, you know uh, the how Alloy actually collects this metrics traces, or whatever information, right, from Redis, and pushes it to Grafana, right? And thanks again, Ashwin, for this insightful session. So I'll now continue with my session. That is end-to-end telemetry correlation, with a sample Java application, and how it seamlessly works with Alloy plus LGTM. So LGTM stands for Loki, Grafana, Tempo, and Mimir. So Loki is for logs. Grafana is the visualization tool which Ashwin has created a dashboard for Redis, right? Tempo is for traces, and Mimir is for capturing the metrics, the time series data. Mimir is Prometheus compatible. But in this example, I have used Prometheus. So just to have that local factor, right? So the complete demo is in my local. I have used Docker Compose, the best way to host it in local for a demo. All right. So yeah, this was a quick tech stack you can say about what I will demo. But yeah, coming to the the problem, right? The actual problem, or the queries which I get from the developers or the SREs, the DevOps guys. So we see we have three different signals, that is metrics, logs, traces. There's an incident. How we investigate. We need to jump from one signal to another signal, check the metrics, the spike, then collect the time frame, the move, and then have a separate dashboard or separate view for logs. Then from the logs, you need to jump onto the traces with that time frame, and this is time consuming. And also this is a hectic job for investigations, right? To change navigate through screens and dashboards, and try to manually understand how these signals, metrics, logs, and traces are related. Now that's where uh, correlation plays a key role here. If you want, because of course the incidents we see is in production environment, right? And you don't have much time to actually investigate and investigate and solve a problem or solve an incident. Your meantime recovery should be MTR should be sorry MTR should be less, right? You need to recover the system fast, for which you need to investigate fast, right? So correlation helps you do that if you implement it in right way. And in today's in today's world, right, we do have a production grade implementation for correlation. Now, if you see the stack which I have used here is Java Spring Boot application, for which I have used a hotel agent, which instruments the application to emit the traces, logs, and metrics, which we'll see in the demo. Grafana Alloy, which is a collector, which receives the signals from the hotel agent, which instruments the application, and it processes as batches, as Prometheus, scraper Prometheus is inbuilt in Alloy. And the whichever like signal comes through the hotel agent as a hotel receiver, massages, renders the signals, and forwards it to the backend systems, right? As a Loki is for storage and querying of the logs. Tempo to store the traces here, and query through Grafana. Prometheus is to the metric storage and exemplar support. Exemplar keyword. Remember this keyword, because in the documentation, I'll show you why exemplar is very important. How Prometheus adds an exemplar to the metrics for us to navigate, correlate the metrics with logs, and logs with traces, and of course vice versa. Like through traces, we can navigate through logs that we'll see on the Grafana dashboard, and of course Grafana, visualization with this correlation links, right? So this demo, I'll create a GitHub repo and share it in the chat, so that anyone can just download it, run some commands, and your setup will be up and running, right? This is just to start with, because as observability is a vast area, and nowadays we are using multiple languages. There are scripting languages and new languages coming in, and we need to have the right tools for the tools to scrape the metrics, and the languages or the apps generating the right metrics, logs, and traces for the components like open telemetry or Alloy, to actually correlate between these signals, right? Coming to the architecture, so I've instrumented a Java application, auto instrumented with the hotel agent. Now, hotel agent, what it does, it creates spans, which means creates a trace ID, a span ID, the definition of that span, and it injects these two into a logback MDC. Now, application emits the logs. Every log line, is is added with the trace ID in the JSON, and with the help of micrometer, I'll just show there's a code snippet as well. What does micrometer does? This captures the trace ID as an exemplar, right? So exemplar helps to actually navigate from the metrics to logs, and then from traces to logs and logs to traces. And then all this data, the spans and everything via OTLP protocol or gRPC protocol, is it pushes to the Grafana alloy. Now Grafana alloy, what it does is it batches the traces and pushes to tempo. Exporter comes into picture once it gets all the details from the hotel agent. Once hotel agent pushes the details to Grafana alloy, it sends the traces as batches to to maintain the load, because it's our side where once we have traces are heavy because they have the multiple services which can be viewed through traces, and it has got a lot of information, so it processes in batches. That configuration is also already available as a documentation in official Grafana alloy docs, right? But you'll also see an example here. Logs are then exported through the hotel collector to the Loki endpoint. Prometheus, its inbuilt component in the alloy, it scrapes the metrics and writes to the the Prometheus. Here in this case I have taken lightweight Prometheus itself, but you can also use Mimir to store the historical data, because it's having the storage blocks with it. It's a different mechanism altogether, where you can store the metrics for a longer period, right? So the alloy, as I said, the exporter pushes the data to the backend tools, that is Tempo, Loki, and Prometheus. Once these are collected, these tools are configured as data source. Okay, data sources configured with cross signal correlation links. So alloy does the magic. It correlates everything and pushes to the backend. Each of these log lines or the traces and the metrics has a trace ID with it as a column, right? That we'll see on Grafana dashboard how we navigate. But this is the architecture flow, how the correlation happens, right? Right. As I said, the every request gets a trace ID that is embedded in all these three signals. This trace ID actually helps to navigate between these three signals. Yeah. This is just detail about how the trace ID looks, and it is created once per request. How it goes, every log line emitted during that request, injected by, as I said, right? Hotel injects into MDC, and from there it pushes to alloy, right? Metric exemplars, captured by micrometers hotel bridge. So I do have a snippet. I'll just try to skip this part, show the snippet to have better understanding. Now if you see the first flow, metrics to trace, yeah, just for example, like P95 latency spike at some time. Now if we click the exemplar dot on that spike, what it does is it shows a trace ID at that timestamp, and when we click on that, it immediately takes us to the traces, the tempo data source. So no, you did not run through the screens, navigate through the screens manually to understand where it failed, what are the traces at this timestamp. So with one click you can actually from metrics you can jump onto the traces with this trace ID, right? As you can see, yes, once you have opened the tempo, you'll be able to see the you'll be able to see the full call tree with each span duration. Now that we'll see on the Grafana dashboard, right? So what exactly makes this possible, right? In for this is for Java example, but you got a full document for Python or Go or any other languages where hotel instrumentation is possible, right? So in here for Java, there's application dot properties, and then the micrometer I was talking about, right? The micrometer tracing bridge hotel dependency. So you just need to add this micrometer tracing bridge hotel as a dependency in your POM or Gradle, whichever build tool you use. And this bridge makes actually the tracer read the current span, the global. So this is a bit deep dive. You need to understand what is a global open telemetry. But yeah, the usage, right? I'm more focused on the usage, which are the tools. How does the flow happens? How the correlation happens. So I've considered Java example here. So by using this dependency, it calls and extracts the trace ID as an exemplar label. This all happens in the background. Yeah. And then the Prometheus endpoint exposes exemplar in metrics. For example, if you see this line number 134 or line number 133, so we have got HTTP server request seconds bucket with all the labels like no method is post, URI this, and trace ID. Now this is the exemplar. The trace ID equal to some alphanumeric value with some time format as well. If you see here, this bucket was last filled by a request that took so and so and had a trace ID, right? So in the backend, the tools understand that okay, this has got a trace ID, and each of the requests are embedded with this trace IDs, right? That you see here, and this trace ID has the again the ability to as an exemplar ability to navigate through the Grafana screens. All happens behind the scenes actions. I'm just trying to explain how this correlation happens, and there will be various applications, right? As a microservice architecture, we can even deploy Redis as a service on Kubernetes, right? So it can be a technical product, it can be an business application, it can be message based application like Kafka, it can be the cache based application or the Redis, which we have seen in the previous session, right? Now everything can be monitor, everything can be observed, and with the right tools, right? If application in this case, the open telemetry has instrumented Java application and produced the spans and the traces, right? The trace ID, right? So similarly, each of the products, we need to understand this doesn't work as is for all the the components which I have listed, right? The application should emit the metrics, the traces. Then Alloy can actually see in here, right? So Alloy can actually have that correlation done, and it can push to the backend tools like Loki, Mimir, and Tempo, right? So you see here the Grafana Prometheus data source links exemplar to the Tempo. How does it does in the background is this is the configuration. Okay, in the data source YAML, when we mentioned yes, Prometheus should be added as data source name, here this is 147 line, right? The JSON data has exemplar trace ID destinations. Yeah. So by this configuration, it automatically embeds the trace ID for the metrics to jump to the Tempo. Yeah, that is for traces. Now from log to trace via log key derived fields, right? It's you find an error in the log and you want to check the traces for that particular service or that particular log line or that request, right? So when you search for the query, the log line has this trace ID here, yeah, and the message, of course. Now when you click the trace ID, it jumps to the exact span of the traces. Yeah, we'll definitely see that in one of our dashboards, right, which I have created for this Java Java application example, right? But this is to give you an idea how the correlation happens and how best you can use these tools to have the correlation done and visualize on Grafana, right? So this is just a code, right? How this correlation happens. So MDC, as I read, the MDC will help us put the trace ID, the span ID, then the trace flag. In this is for Java, so it can be different for Python, Go, and other languages. And once it is done, right, it produces this JSON which has a trace ID. Okay, So this JSON then push to no Alloy, I mean OTL or OTPL receiver. Alloy receives it, and then it pushes to the backend tools. All right, yeah, just like this. Okay, so it converts OTLP log records to Loki entries, preserve the structure of JSON body, and mapping hotel resources attributes to Loki labels. Right. So this is as I was repeatedly saying. Right. This is all the backend work which is done by these tools. You as an let's say if you're a developer, right, you should be more focused on the hotel instrumentation, how best you can instrument the application, how best you can produce the spans, and rest all these tools will take care of. Again, these are all production grade products. They work seamlessly in production. You can use the Docker Compose to have this setup done. With Docker Compose you can have certain configuration files. Just to show you here. Okay, so you can have in one file build all these services. Even now what I've done is, using Docker Compose, I've added all these components into a single container, right? So I'll show that Docker Docker screen as well, where you see that only one container image is running, which has all of these services. So you can try it out in your local, for instance, and whichever deployment method you feel is better, in your workplace or personal space, right? You can go with it, because in Kubernetes requires some specific type of deployment, right? Once the container image is built, if you want to have multiple microservices as these components, right? Just you can go for it, like Alloy as one service, or the Java as other service and everything. But this example shows how Docker Compose is used to add all these services into a single container, right? So all these configurations are added, so that on Grafana the data source is created, Prometheus starts scraping, and Alloy starts receiving the signals and pushing to the backend, right? And quickly show you the Alloy configuration as well, how this happens. Right, so as I was explaining, yeah, so Java hotel agent traces to OTLP, on this port logs and Prometheus. So Alloy routes all these signals to the backend tools like Loki, Tempo, and the Prometheus or Mimir, right? So this is the configuration to receive. This is gRPC endpoint, HTTP endpoint. You can use as it is, and then output to the batch which I talked about, tracers, right, and the export to Loki. So these are all syntax from Alloy. You can use as it is. If there are if you want to configure more with respect to the application, there's already good documentation available from Grafana, right? So this is like batches, I said, right, to handle the load. You can define the batch size, the timeout, if it is getting delayed, just to have the load balanced, for these the traces. The batches is ideal for traces, right? uh, and then the exporter, right, to endpoint. Okay, so Tempo runs on the local. So these are all locally built, and deployed as a single container. Right, similarly log exported, as the exporter take care to write the logs to the Loki. Okay, the exemplar part here, I was trying to show. All right, request open matrix format to preserve exemplar, right? So this is a default one, like format open matrix text. You can go and have read about, I don't know, different formats you'll have in the documentation and apply here. Ultimately the remote write URL for Prometheus for writing the metrics. Right, let me jump on to the readme, and I'm just trying to relate this documentation with the configuration, right, so that you guys can understand how this correlation works. But yes, you'll see that in action as well. The demo is already running in the background, generating some metrics, logs, and traces. Okay, so For example, right, if you, let's say there's a slow trace in tempo, and we want to see the log lines, open a trace, you will see a log tab. Once you click on that, it will, the trace ID, it will take you to the logs, view. Okay, there you can see the, without any manual, considering the time frame or something like that, it will exactly pinpoint the time frame, where what happened during this incident. Okay, and these are like snippets, what we have seen in that configuration files. Um Right. So these are more details about, how this correlation happens, and so I just try to put, explain with the code, right? I have taken the code snippets, and this is like a deep dive. Of course, I'll share this repo with everyone, so that you can go step by step and understand, from application perspective as well, like, in the order surveys, how you, do the, how you can write the spans with respect to your, applications. Okay, listen metrics with exemplar. Yes, so there's a I mean, this readme gives a beautiful understanding of, for this example it's only Java, but now there are several other examples available online, for Python, Go, and other languages as well. Okay, I'll not deep dive into this. Of course, you can go through this later. But how important is this, because I said, right. See, from a traditional tools perspective, every signal, metrics was having, like, they were all working in silos, and they did not have any correlation. And these tools, actually gives us the correlation, a better understanding of what happened in this time frame. All right, when there is a spike, how you can navigate on the Grafana by just one click, yeah, from logs to traces, or maybe from traces to logs, from metrics to traces, right? So, this is like a basic example. You might have, enterprise level applications with you, the technical products with you. Now, if you want to deep dive into the Redis cache mechanism, right? Ashwin is available, right? You can poke him, you can trouble him to, understand how the telemetry works for Redis. Yeah. So I've just, added a load test script, simple script, which generates load, which is already running in the background, and it's continuously like generating the metrics, logs, and traces, right? Just in the interest of time, I've done that. Yeah. So let's jump to the uh, Grafana dashboard and see that in action. Okay, let me stop and share my screen again with the Chrome window. Just okay. So this is the order service dashboard, simple dashboard, just for the understanding of how correlation works. I created, and this has the metrics. Let me just, okay, metrics, logs, and traces as panels, which will give the insights of the, yes, yeah, which will give the insights of the Java application which is running in the background. Now, if I click on the metrics, and now if you see here, right, so it gives the metrics, basic metrics, and this is just a simple basic, uh, you know, view. Okay, and right, okay, all right. Let me jump to logs quickly. I'll come to metrics. So yeah, here you see these are like the application logs tab, and then you have got error and warnings tab here. Okay, so what we see here is, okay, this is the error. When we click, right, it gives you the details of, let me just uh, zoom. Okay, I think this would be much better. Yeah, right. So it gives you the, logs, which are, because I am running a batch in the backend, which generates the load, and it also generates the, some, errors and warnings in the background. So you can see the logs here, right, which gives you the all the attributes here, the warning signal. Now coming to the, yes, here you see the trace IDs associated with each of the log line, right? Okay, and let me expand. Right, here you see the fields of each of the log lines, the level, the job, and then the lot of details. And here you see the trace ID. Okay, now let's go to the traces here and see what happens. Okay, so we have got trace IDs here, and one of our service, order service, generate background load, is having a trace ID. When I click on this trace ID, it will take me to the traces, right? Now I need to expand this. You can also have the span filter. Click, for now we have only one service. What are services you have deployed, all can be viewed once you instrument it. And the span name here, right, that's defined, as shown the code, the example, right? So you need to define those spans. Then you'll be able to view on Grafana. So once we have this span here, yeah, so logs for the span, I click this, it immediately opens up the log panel here, and it shows me the details, the logs exactly, right, at this time. So if you see the compare, just compare it, right? So we have traces at this time, 11 dot 11:22 somewhere. Yeah, now if you see, it's the almost the same time, right? Just I think maybe some milliseconds of difference, right? So it jumps to the, with the help of trace ID. This is how correlation works. So in the traces, if you see, okay, you have some error, and then you click on the logs, it will take you to the exact time frame of that logs, and just you start investigating, okay, what happened to this service, what is the error. Maybe for example, let me close this, right, let me go to explore, uh, or maybe the dashboard. So you see any error here, right? So you can copy the trace ID as well, and go to the exemplar, sorry, go to the explorer, and try to search for it. It will get the logs for you. From there you can navigate to traces as well. But now this gives you the holistic view of, let's say there is an error, right? Let me go to one more traces. Okay, click here, and then you can also expand the span attributes here, which will give you all the spans which were created, the default one as well as the ones which were created, right? The resource attributes, right? And then just click on the logs for the span, and it will take you to the logs dashboard, or the logs viewer. Okay, then here you can just modify or see, what if you're looking for a specific string or something right, you can just add it to the query, and try to check the error logs here. Yeah, so this is how the spans work. This is how correlation happens. And on the dashboards, I think Matrix doesn't have much data now. I'll check that, but yeah, this project will help you understand the basics of correlation. at the if you're looking at something like this, know how you relate these signals, and do not understand how correlation works. I think this project will help you, to start with. Then yeah, of course, we have lots of documentation available on Grafana official page, which will help you, try to understand. You go for open telemetry as well, because open telemetry is the one which actually, you can define spans. The attributes which you see here, right, are defined by the open telemetry. Then alloy is used basically to, process through patches for tempo. As I said, it's basically a pipeline which massages these requests, coming through metrics, logs, or traces, and pushes to the backend tools like Loki, Mimir, and Tempo, right, and visualize on Grafana. So this is how correlation works. This was just an example again, but it's a production grade project. You can take it forward, test it in your dev environment, or anywhere, and it works seamlessly in a production environment as well, right? So that's all from my side as part of this topic. uh, the uh, I hope this was, at least to start with, right? This was helpful, and okay, hold on, let me just bring this back. Right. Yeah. Okay. Yeah. To start with, this is just again the basic example, but many of the developers or SREs, or DevOps, or they don't understand the power of correlation. Yeah. So the tools are available. We do have the mechanisms. It's just about understanding. Yes, I understand there are too many tools again, but you need to also look at the outcome, right? How easy it is to navigate through these signals when configured it correctly through these tools, right? So you have used open telemetry, we have used alloy in the long run, because we are coming up with the AI workloads, right?
Yes.
And those are like, I mean, if you go with the rate, to just navigate through the screens for metrics, logs, and traces, and God help you then. Okay. So because Redis, you've seen the case, right, how insightful the the all the signals were there. uh, I really like the dashboard, Ashwin, because that shows the power of these metrics or logs or traces, right? How
Yeah.
important they are. And as you said, we can build screens for each of these roles. And
Yes.
I was repeatedly saying the roles, right? Because it's not that, because SRE comes with certain queries, certain their own experience based questions, right? The developer comes with their own set of requirements, that okay, I know I want to visualize the for example, Java, right? In the Java, they want to instrument maybe their JVM related threads, JVM related metrics, right? So how do they do that? And then how they relate those application metrics with the logs and traces, and how easy is to navigate through this, right? That question comes in, like these obvious questions. And as developers, or SREs or DevOps, we do have our own set of questions with respect to the applications as well, right? But these tools enable us to have these signals configured, have this correlation done, and effectively investigate an incident. And there is a lot more to this. I mean, you can automate, like with the Slack, with Teams, create a Grafana incident. And
That's
this is a really vast topic, right? But
right.
this correlation actually helps you, understand. Okay, when you post it on a Slack channel, right, you give a trace ID, right? You can configure and tell, okay, this is a trace ID. And maybe a bot or human just go on Grafana, try to investigate with the trace ID. You just enter the trace ID, you get the entire history, what happened to the metrics, where it spiked, what are the error logs, what is the error message, then where the service failed. Here I have only one service, but let's
Yeah.
consider there are five services, and traces actually tells you which service failed, right? From there, if you click the logs, then it will take you to the particular service logs. It will not come
True.
to the time frame where the original request has generated, right?
Yes.
So that's how it helps. Yeah, and this project, it's a starter. I think on local, because again there are environment constraints. People don't have the right environment, maybe, yeah, to start with. But yeah, this is a very lightweight, basic project. I think people can start with. I'll share the GitHub link later on.
Sure.
Uh,
I'd love to go through the demo and the code as well. Yeah, for sure.
Sure. Yeah. So that's all from my side. All right. I hope the attendees have enjoyed the session, got insights from the Redis community. Thanks to Ashwin joining us today. This was again on a short notice. I know, but yeah, we made it. In fact, now I'm glad and happy that we collaborated. Yeah.
Happy to be here.
Anything from
Yeah.
you, Ashwin?
Yeah. I'm glad to be part of the community as well. So, and thanks for your session. I found it very useful. I'd love to actually go through maybe during the weekend and see more of
Sure,
your project as well. Yeah. Yeah.
sure.
So, yeah. With that being said, I think it's a exciting space to be in. One of the things I particularly liked is, like, I think Grafana Cloud and also Redis Cloud and Grafana Cloud both offer generous free tier. So for
Yes,
this, the demo that I used, where I remember when I used a few years ago, there was a lot of manual work involved in creating a dashboard. Now
yeah,
it's even more easier with you can actually use Grafana Assistant to create a dashboard. So it was very useful for me to,
absolutely.
yeah, to do a little bit of fine
It's
tuning over there. So
No,
actually
I
create,
completely agree with you, Ashin. Yeah, it's powerful. It saves your time. It gives you the desired, output. I think as a dashboard, right? And from these sessions, what I understand is you focus more on the product, rather than the observability. For observability, you have tools. Tools enable you to see the system insights, but the right configuration will give you the desired results, right?
yeah,
As I said, not every application is the same, or not all the application configurations are same.
right,
There might be different use cases, for which, I think that's why I created a basic project and gave the snippets. How does logging works, with respect to Java. How can you actually create a span. Now, how does the trace ID look like, right?
yeah,
So
yeah,
that's where people need to, the users, whichever role you are in, you need to focus on these kind of technicality, and rest all, open telemetry is there, Elo is there, your Grafana products are there, which will help you to give the insights and performance of your systems. Yeah.
very true. Yeah,
All right. That's really great. Happy that this sessions really went well. And no, let's close this. And the session is recorded on YouTube, so it's always available with the Grafana and Friends Hyderabad channel. You can, anyone can view anytime. Yeah.
and feel free to reach out to either of us for further discussions. Yeah,
Yeah, absolutely. And thanks again, whomsoever has joined live, and on a Saturday, right? On a Saturday, they spend time to listen to a session. Thankful to them, and hope these virtual events come more and more, as global meetups, right? So Ashwin is from Bangalore, right? I'm from Hyderabad, so we are connecting within India. Hopefully we'll get speakers from outside of India as well. Last time we had Ima from Grafana Labs, so she's based out of India, sorry, outside of India. So no, we are looking for global speakers as well, right? So through this video, maybe whoever watches this, if any speaker, global speaker, who's having good content on any of the in the observability area, right, in the observability space, right, I'm happy to take it up and give an opportunity in the virtual sessions. Yeah.
Sounds good.
Okay, cool then. Yeah, thanks again, Ashwin, for joining us today on a Saturday, right?
Yeah.
And giving a really valuable and an insightful session.
Yeah,
Thank you so
likewise.
much.
Thank you for your session as well. Looking forward to doing more of this. Yeah.
Sure. Yeah. Thank you.
So,
Yeah.
see you all. Bye.
Yeah. Bye bye. See you.